All right, everybody. Let's jump into this review real quick, and so we'll move as quickly as I know how to go. And slope of a line passing through these 2 points, okay? The best way to do slope, I think, is delta y over delta x, which means rise over run, classic. So how do you find delta at y? That just means the change in y. So how does y change when it turns from a 5 and magically turns into a -3? So 5 down to 0 is 5, and then down 3 more is -3. Think of it as like 5 degrees outside, and now it's -3 outside. How much did it drop? That's a drop of 8. Okay, now 6 going to 5, that's a change, a drop of 1. So this is just a slope of 8. Cool, right? Pretty easy, yeah. All right, next step. Perimeter, oh my gosh, just add up all the sides. 11, 3, 9, 3, 3. And so it's what, 18 and 11, 29. Fun. Perimeter, just take a walk around it, right? All right, solve the proportion. Ooh, I hope that you guys got this one. 12 equals 12x, and divide in x equals 1. Hopefully they're all just that easy, right? All right. What about this one, though? This one's a little different. This one you need to start remembering your properties. Now, you can use your postulate sheets on this test. Postulate sheets are only as good as the person that's looking up stuff and can figure out where to find them. So one of your theorems says that when a chord crosses a radius at 90 degrees, that radius bisects the chord. So in other words, this piece is congruent to this piece, so x equals 3. Okay? All right. Let's keep it rolling. Number 5, geometric mean. Geometric mean, we just remember regular mean is when you add them up and divide by 2. This is the opposite of that, or the next level of that, I should say. And that's when you multiply them, so 4 times 16, and take the square root. So that's geometric mean, and so this would be 64, and that's just 8. Well, that was easy. All right. Area of a trapezoid, in terms of square meters there. Pretty easy. So area, trapezoid, got to know the area of a trapezoid. This is something you've probably been doing since for a very long time, we'll say that. All right, so base 1 and base 2, we'll average them up. So 2 plus 16 over 2. Okay, so it's the average of the bases times the height. Okay, and so 2 and 16 is 18 over 2. Carry the 2 and divide by pi. I'm just kidding, this is all 90. Okay. All right, this one has been coming up a lot lately. So hopefully you get this down. So this one, it says PS, just start labeling everything. So this is 18, RS is 9, PQ is 20. Well, the cool thing about this one, we'll call this X, is that there's a cool relationship. This side is to this side, just like this is to this. And so you set up a proportion. We do 20 is to X, just like 18 is to 9. And you can tell that's just going to be half, so x is going to be 10. But you can cross multiply and do all that stuff. But either way, 10 is your length there for number 7. Number 8, find the distance from point to the line y equals 5. Now, whenever you get a line that's y equals 5 or x equals something, you got a vertical or horizontal line. This is a horizontal line, which makes it really simple. So you got a horizontal line, and you got a point -8, 1. So you can, my pen's been a little shoddy lately, sorry about that. Anyway, so you can make you don't even have to draw an official graph. You just sketch this line. There's y is at 5, and then -8 is like, and then 1 is like here. Well, how far is it if you're up to 1 now to go all the way up to the line? That's a difference of 4. So this is just 4. That's all. So anytime it's Horizontal or vertical line, that should be an easy problem. Just look at the difference from that value, the y value, to that line, and that's your distance. All right, number 9, train number 9. We got a regular hexagon. Okay, so let's search through regular hexagon. Side length of the garden is 8 on a blueprint with a scale inch of 1 to 10. How many feet of fencing will we need to surround the garden? So all you need to really do here is that one of the sides of the regular hexagon, so it's going to be 6 times whatever it is, one of the sides is 8 inches, and they're saying 1 inch is the same as 10 feet. So this is just 80 feet, so it's 6 times 80. You got 6 sides, and that's it. So 480 should be pretty easy. How many faces does a polyhedron have with 14 vertices and 18 edges have? Okay, remember your formula. Okay, V plus F equals E plus 2, and just plug those values in. Now, how do you remember which one goes with 2? There's any number of ways to remember it, but one way is to say E is the most popular letter in the alphabet. Did you know that? So to put E over there with 2 because he's twice as popular. I don't know, however you want to say it. Just think about a good way to remember it, and E goes with the 2. V plus F equals E plus 2, and just plug in 14 there, 18 there, and solve that rascal. And 10, this E ends up, or number of faces is 6. Okay, good stuff. Number 11. Number 11, let's go through. Triangle is equiangular. Nice. Perimeter of 27 inches. Well, it's equiangular. It's also equilateral, which means x, x, and x. So this is 3x equals 27, because their total is just the sum of all of them. And so then x must be 9. So each side is 9er. Good stuff. All right, moving on. I've seen this one like this before anyway. Rectangular frame divided, okay. One thing you know about parallelograms is that this piece is congruent. Diagonals are bisected. But the cool thing about rectangles is that diagonals are congruent. So this piece is this piece, is this piece, is this piece. So what's the length of QR? Just 34. Double that. Fun. Number 13. Measure of AB is given by 6x minus 17. Measure of xy, blah, 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 blah. It's given that these two are congruent. Really? Is this that easy? Okay, if they're congruent, then their measures are the same. So 6x minus 11 equals 4x plus, or 17 is 11. And then just move that x's to one side and the numbers to the other side. So this subtract 4x to be 2x. And then add 17 to both sides. Okay, so that's 28, and x equals 14. Plug it back in, and you get 67 degrees, plugging into each of those spot faces. All right, what is the included side of J and K? Well, angle J and angle K, the included side would be JK. Okay, so JK. And the included angle of JL and KL, what's the letter they have in common? So you don't have to draw the picture on this one. And so this would just be angle L. Okay? That's the one that these two sides make up. Number 15. Find the unknown length of the triangle below. Do the side lengths form a Pythagorean triple? Well, this is just 11 squared plus 17 squared equals x squared. Okay, ooh, is my calculator open or not? Let's see. I should bust this out. Oh, yeah. Okay, it works with this thing. So there we go. 11 squared plus 17 squared. And then we'll take the square root of that. And now I get 20.25. And no, that is clearly not a Pythagorean triple, okay? Or square root of 410, I guess you could also leave it there before you go. If you want an exact answer, that's that. If you want a decimal answer, it's the other one. Okay, cool, that was fun. Next one, find the value here, write your simplified radical form. So again, Pythagorean theorem, 3 squared plus 9 squared equals x squared, because that's the hypotenuse. And so this would be 9 plus 81 equals x squared. And this is 90 equals x squared. Then we'll take the square root. Okay, and the square root of 90. Well, how do you take square root of 90? Well, I'm going to look for, some of y'all struggle with this. How do you like fix 90, that square root there? And one of the ways you can do it is look for perfect squares that divide into that. So let's write down our perfect squares. Just the first 5 is probably fine, but 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and then you go 36, whatever. So which one of these numbers could divide into 90? Well, clearly 9 would. So let's pull 9. So square root of 90 is equal to square root of 9 times 10, right? Y'all agree with that? Which is the same as square root of 9 times the square root of 10, which is the same thing as 3. Rad 10. Okay, so that's how you rationalize, fix that denominator, clean it up a little bit. All right. Number 7. Okay, I love these things. All right, so these problems are all the same. Yeah, they use the same formula, even though they're asking for different things sometimes. So here we go, area of a sector. We're talking about area. So there are 2 types of problem. One talks about the crust of the pizza. One's talking about the actual pizza, where you put the cheese and everything, and the anchovies and the jalapenos, whatever gross things you put on your pizza. All right, so the key on this one, the area, when you're thinking pizza, all right, so it's going to be part, come on, pencil, over the whole equals part over the whole. Now this is, you're like, that's not a formula. You're right, it's not. It's kind of an expression to figure this out. All right, so this, I always put my degrees, I always make this first one. So degrees, the part over the whole for the degrees. So let's do it here. I look for the problem, it gives me the part. It gives me 280 degrees. So just put 280, but what is the whole degrees? Well, that's 360. So it's pretty good. It's a healthy slice of pie there, all right? So that's almost the whole thing, you hog. Come on. All right. And then we're going to talk about the part over the whole here. We want the sector, so we'll call that x for now. And then we want to give the answer in terms of pi, so that just means keep pi along for the ride. Okay? Now, what goes in the denominator? That's the total area of the whole thing. This is pi r squared, because you're talking about a circle. Pi times the radius squared. Okay? Well, that radius is 12, so I'll just put 12 in there now. Okay? All right. Good stuff. Now, cross multiply and do all the things you do. But don't multiply pi through there. Just leave them alone and carry them along for the ride. So 360x equals 280 times and 12 squared, 40320 pi. Just keep pi there, right there. Don't even worry about them. And then divide that by 360 to get x by itself. And x equals 112 pi. So when you cancel out that 360 out of there, pi doesn't go anywhere. He's just hanging. Done. Okay? That was fun. I hope you enjoyed it as much as I did. Maybe more. All right. Parallel, perpendicular, or neither. This is a gimme. Focus on your slopes. Put it in the right form. This one's barely out of form, so you can tell what the slope would be. And so clearly they're different. So just say neither. What are the possible values of x in this triangle? Well, you could think about this a couple ways. You could say, hey, if this 3 length were to hinge down and close like this, then this would be 3. How much would be left to close our triangle here? And if it was almost all the way down, 3 and 5 make 8. So you're good. Now, and then you could also hinge it out like this and have a really wide triangle where it's 3 and 8 put together. So the shortcut of this one is to say your values are between the sum and the difference. So in other words, 8 plus 3 is like the maximum size you could have. Let me move it over here. So 8 plus 3 is the maximum you could have. So x has to be somehow less than that, because if it was too long, then your sides wouldn't reach. But it also is less than, 8 minus 3, so the difference of those two. So it's going to be bigger than the difference, less than the sum. That is the triangle inequality theorem. Okay? So fun. That says draw a net for a trapezoidal prism. That sounds like fun. Trapezoidal prism. So prism with trapezoid bases. That's all that means. So just make your trapezoid, make your Pizza Hut logo. Try to put it in 3 dimensions here. And yours might look a little different, but you get the idea. All right, that was fun. And you could draw it in different perspectives, and likely you're looking down on it or whatever. So whatever floats your chicken is fine with me. Here we go. A school provides bus service only to students who live a distance greater than 2 miles away from the school. On a coordinate plane, the school is located at the origin. Blah 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 blah. Okay, so he's living on this line right here. This is his line. It doesn't even matter where it is. That's not what it is, but you could sketch it if you wanted to, and that's the origin. You know what? Let's do this one for real. Let's put it on a graph. Do I have blank graph still? All my things closed out, and so I don't know how to find them anymore. Hold on. Blank graph. Yay. Ooh, and I still have the problem on here. All right, so I graphed the line, and then it said it was at the origin. It said they were at the origin. All right. So if you're at the origin, that means, and the question is, if you read the question, it's asking, is it possible that he's, we're not doing this one. Is it possible that he's close enough to the thing? Is he far enough away to get a bus ride? Slacker, just walk. It's less than 2 miles. So the fact is, it is less than 2 miles, because if you look on the graph, the school is at the origin. And so because the school's at the origin, this is definitely less than 2, because 2 is like, this far away and that far away. Now, if you want to do like the official way for this, you need to find this length right here. And how do you find that length of distance from a point to a line? You have to find the perpendicular slope, use the perpendicular slope, and use this point, and then see where those two lines, make a line from that, see where those lines cross. But you can draw, for this one, you can just draw a picture and see if it is 2 or not. This is kind of a simple one. Okay? So hopefully that gives you enough to work with there. All right, on to the next one. Apparently I've done this one before. Oh, I have. So I'm just going to walk you through it so I don't have to draw it all over again. All right, it says prove algebraically. What does it mean to prove something algebraically? It means you show how the algebra shows that it's true. So algebra means letters, and we're going to be using letters in here. So I would start by drawing the 2 triangles, ABC and QRS. And the perimeter of their sides is 1 to 4, so make one just like quite a bit bigger than the other one if you want to make it look accurate. Anyway, so the goal is to prove this right here. It says show, pardon the interruption, guys, I'm sorry. The junior high girls basketball are headed to the gym. Good luck, ladies. Go Titans, let's get ready to rumble. All right, anyway, so let's look at what we're trying to prove here. It says you want to show that the perimeter is 1 to 4. How do you show the perimeter is 1 to 4? Basically, it means that 4 times the perimeter of this one is equal to the perimeter of that second one. If I can show that, that is how you get your perimeter to be 1 to 4, okay? So 4 times the perimeter of the small one would equal the perimeter of the other one, and if I can show that, I'm good. Now, first things first, I've labeled my sides with little letters there. They're always across from the big letters, the points there. So these A, B, and C add up to make your perimeter. That's how you find the perimeter. Now, for the second one, though, each side is 4 times the length of the other one, because that's what it said here. Their corresponding sides are 1 to 4. So that means I put 4A, 4B, and 4C there. Now, perimeter 2, the second triangle, is 4A plus 4B plus 4C. But when I add those up, I can factor out a 4 there. And when that happens, I've got 4 times A plus B plus C. But hey, over here, look, a plus b plus c is the same thing as p1. So doesn't it make sense that I could plug p1 right here and get p2 equals 4 times p1, which is what we're trying to prove, and we're done. Okay, so that's an algebraic proof, just walking through. A little confusing at first, but just take a breath, take your time, draw the two. It's not bad. All right. Unfortunately, this thing always prints funny. This is parallel. This means parallel. It says if you have parallel lines here, what is YZ, length of YZ? You've shown, so one of our, from mid-segment lesson, says that if you have a midpoint here, which this shows that W is a midpoint, and you have parallel lines, then V is also a midpoint. And once you have two midpoints connected, you have a mid-segment. And once you have a mid-segment, then you know for a fact that this is twice the size of the mid-segment. So this is 2, this is 4. That's it. That was about as easy as it gets. Okay? All right. Oh, and I just realized I made a mistake because it did say draw a net. So y'all didn't correct me on that one. I'm blaming you. I'm just kidding. You're not even here. A net for that would look like 4 rectangles. Sorry about that. I'm just going to go back and hit it because I can. So 4 rectangles, and then it would spring off. Let's see, this one. And so you can just think about like a little takeout box or something like that. There we go. But there's other ways to orient the same net. And then you need the top. So there's the top for the box. So anyway, name the inscribed angle shown in the circle before. All we have to do is name it. So inscribed just means inside. So it's this one right here. And angle N would suffice, or angle MNO is fine as well. That wasn't so bad, was it? No, it was not. Let's see, what else do we got to do? 20. It says write an indirect proof here. I'm just going to talk through this proof real quick. It says 4-2, if there's a line and a point not on the line, exactly one point contains them. So again, statements and reasons here. We'll move a little bit quickly with that one. First things first, suppose indirect proof. You're going to start by the other one. Let's say that AB does not contain C, okay? And you're going to say AB and point C cannot be contained by a plane. So suppose there's not exactly one plane. So suppose you have A, B, and C, and there's a line. So suppose A, B, and C. So A, B is your line. But suppose those 3 points are not defined in a plane. A plane. Okay, so the very first step is to suppose not. What if it didn't contain them? So it's not in a plane or whatever. So if they're not in a plane, well, guess what? They're not collinear. Are not collinear. Okay, not in the line. That's given. And because it's not that, we can say postulate 6 says there is one plane. So postulate 6 says A, B, and C, because they're not collinear, define a plane. Okay, so that's your contradiction, and therefore the assumption must be true. So suppose for a second they didn't define a plane. Well, they're not collinear, that was given, and by postulate 6, A, B, and C do define a plane. Okay, that's all you need. Classify a three-dimensional solid below. You could kind of say it must be square pyramid. It could be a rectangle down there. It's hard to tell for sure, but I would say this is a square pyramid for number 27. Or rectangular. It's kind of longer here. It's hard to tell. It's at least rectangular. Well, could it be a parallelogram down there a little bit? Probably not. It's just hard to see two-dimensional, in two-dimensional. All right, so I've already done this one for a class or two, so I'll just walk you through it real quick. It says, we're looking at these statements. You got a statement P and a statement Q. I call those P and Q just to find what they are. Conjunction means and we use this symbol right here, it's a little and symbol. And with that symbol, we just know that both things have to be true in order for it to be true. So to start by setting up your table, true, true, false, false, true, false, true, false. That's always how they start. Then P and Q, that's true, false, false, false. And why is that true? Or why is it that way? Because to be true here, you have to have both things be true. Like if I said, hey, I'm going to give you $1 million and a frog, okay? And then I just gave you a frog but didn't give you $1 million. Did I lie to you? You can be like, bump the frog, where's my $1 million? I'm ready for it. So if I don't hold up both parts of that thing, if I say I'm going to do this and I do that and I'm going to do this, then I lied if I didn't do both of those things. So it's going to be false for all of the other ones. Okay, so it's only true when both are true for conjunctions. Disjunction is or, and only one or the other could be true. All right, let's see. Find the arc length. Okay, so this is closely related to another one we did here where we're talking the area of a sector. And the arc length of a circle, okay? Again, part over whole. Part over whole equals part over whole. Okay? So part over whole equals part over whole. What is the part? What is the whole? All right, start with your degrees. So 120 over 360 equals, now part is going to be, my part is, this case, arc length. Arc length is referring to, on the pizza, it's just talking about a piece of crust. So it's like the crust on a single piece. It's just a little bend in the whole thing. I'm talking about just the crust. So the part, we'll call it X over the whole. What is the whole? Well, the whole is, this time is referring to the whole crust of the circle, also called the circumference. So that's 2 times pi times the radius, which is 6 in this case. So 2 pi r. Cross multiply, so this is 360x equals, and pull in the calculator here, 120 times, now it says leave the answer in terms of pi, so just don't multiply them, just keep them there for the ride. All right, 2 times 6, and that's 1440. Okay, and so divide this by 360. Oh, I forgot my pi, hold on. I forgot to bring along for the ride, pi. There we go. And then when we divide them, x equals, this would just be 4 pi. Okay? So hopefully that made sense for you. Order the measures of the angles in the triangle from least to greatest. Well, least to greatest is easy because you just go, the smallest side is across from the smallest angle. So least would be angle P. And then the next shortest side would be angle R. So these are never drawn to scale. And then angle Q would have to be the biggest angle because of the biggest side there, 25. All right. Write the ratio comparing the VU and SR in different ways in simplest form. Okay. Well, let's do it in 3 different ways. One way you can do it is, this is clearly 6. So it's like a 6-to-1 ratio or 1-to-6, depends on which way you do it. So 1-to-6 is one way to express it. Another would be like 1-to-6 like that, okay? Another way is 1/6. So any of those 3 are fine, comparing one to the other, just depends on the context, okay? So fun, right? Right? All right, let's keep it rolling here. Let's see if we can get this knocked out. You guys got things to do. All right, find the angle OYX. Okay, so this is related to that other one. When you have a radius going through a chord, it always, and it bisects it, it's going to be 90 degrees. Or if it's 90 degrees, it automatically bisects it. So it's one causes the other. And so because it's evenly split, you know it's got to be a 90-degree angle. Fun, right? All right. It says use a coordinate proof to show the triangle as an isosceles triangle. So how do you show isosceles triangle with this one? Well, all you need to do is just figure out, okay, I've got 3 points here. I just want to see the length of each of these things. So AB, for example, is equal to the square root. All right, so I'm going to go A to B. So I'm just going to look at the change in x squared. So let's do that, change in x. So 2 went to 8. That's a change of 6. So 6 squared plus 0 went to 0. So that's 0. Well, that was fun. And so the length of AB is just 6 squared, which is 36. Then square root again is back to 6, which kind of makes sense. All right. So there's AB. What about BC? Let's do it in the same colors. BC equals the square root of distance formula, right? We're going to go this time from B to C. All right, from B to C, we're going to go 8 drops to 5, so that's a drop of 3, so 3 squared, plus, and then 0 goes to 5, that's an increase of 5. And so this is going to be 3 squared is 9, 5 squared is 25, and so 9 and 25, that's 36, or 30, hold on. 9, 25, 34, there we go, 34, so I'll just leave it square root of 34. That's fine, you don't have to go for it. You can put it as a decimal if you want, about 5.8-ish. And then we'll do the last one, and it'll be AC. So AC, let's see how these change from A going to C. Let's look at those values and see how they change. What's delta X? Delta X, the change in X, went from 2, now go all the way to C, to 5. That's an increase of 3. And from 0 to 5, because that's the y values, that's an increase of 5 squared. And just like we did before, this is square root 34. Now, if 2 of your sides are the same, guess what kind of triangle it is? Isosceles. Therefore, it must be an isosceles triangle. Sweet Christmas. That was fun. Show that they are similar triangles. Easier than you think. Just 9 is to 3. So 9 is to 3. Just like 12 is to 4, just like 18 is to 6. Well, if all of these give you the same number, then that shows similarity. That's all you need to do. Okay, show the ratio of one pair of sides and another pair of sides, and another pair of sides. All right. It says find the angles. Okay, angle 2 automatically, you shouldn't have to do any work on this one for 35. Angle 2, bam, 90 degrees. How did I know that was 90? Because anytime you have an inscribed angle intercepting a diameter like this, bubbles double, and the bubble is 180 degrees. So this is clearly 90. So angle 2 is 90 degrees. Angle 3, let's look at angle 3 for a second. Angle 3, it's this one here. Notice how we have an inscribed angle again. Angle's on the circle. Everything's touching the circle. That's good. That means the bubble is double. And so 122 is double. So 122 divided by 2 is 61. So we got 61 down here. And 61, and so we'll do 90 minus 61 because the other angles in a right triangle are complementary. So that's 29 for angle 1. Okay, so hopefully that was easy enough for you. All right, moving on, 36. Ooh, we can do it, guys. We can do it. We'll get it done. Here we go. Indirect proof. Indirect proof. If one angle of a triangle is larger than another angle, the opposite side is longer than the side opposite the second angle. All right. So it's an indirect proof. We want to prove that BC and BA. So I would start by drawing a triangle first. Okay, so let's draw a triangle. And all I know is that A is bigger than C. I've got nothing else here. So this is going to be, let's do this. A is a bigger angle than C. I'm going to make them about the same. That way I can kind of see the different images. All right, so we'll call this A, we'll call this B, we'll call this C, and I'm just going to go through. It's given that A is bigger than C. Okay, that's good to know. And I want to show that BC is longer than BA. So the angle across from it, I want to show that this is longer than the one across from angle C, given that it's larger, right? So what I'm going to do is I'm going to assume the opposite thing. So case one, what if they were the same length, right? What if BC is equal to BA? Well, we'll call it this way, BA. Well, if BC and BA were congruent, guess what? Well, that means angle A is congruent to angle C. Why? Because the isosceles triangle theorem. How do I know that? Well, because and that would be a contradiction, so we say contradiction. So why do I know that? Because isosceles triangle theorem basically says, hey, if I know two of my sides are the same, then my base angles are always the same. So if the sides are the same, the legs are the same, the base angles are the same, are congruent as well. So there we go. That one's out of the weeds here. Now let's go to the second one. So that's a problem, because if they were the same, then that violates our given. Okay, so that's a contradiction. Case number two, though, what if BC were less than BA? Okay, so if BC were less than BA, then angle C would be larger than the measure of angle A. Okay, and so if this were less than, then C would be greater than angle. Yeah, that's right. No. Did I say that right? Yeah, let me put measure on there. All right, then C. All right, so BC is less than. Then C would have to be the bigger angle. I said that backwards, didn't I? Yeah, it should be. No, that's right. All right, let me look at it in this picture here. So if BC were longer, all right, I'm throwing myself off here. Let's see. All right, so what we can do is go to our postulate sheets too. And 39-1, so this is 39-2, says if an angle of the triangle is larger than another angle, the side opposite is longer than the second side. So this one is saying, hey, what if BC were shorter? So if BC is shorter than BA, then the angle across from it has to be smaller. So A, yeah, there, I did say it right. Angle A has to be less than angle C because of 39-1. Okay, so go check that out on your postulate sheet. So now, because that's, if that were the case, this would violate this also is a contradiction. So this and this both contradict our given statement here. Okay, so there's really not much to it. You could just write another statement that says this is a contradiction, but that's fine. That's all you need. All right, let's finish this up. Number 37. We've seen a few of these, right? Here's the key on this one. There's two ways to use geometric mean. It says I want to find AD, so let me put an X there because I don't know that one. And I want to find AB, I'll call it Y. So let's go through here and let's not hurt ourselves here. What would this be in this picture? All right, so the key on this one is knowing the formula to say that, hey, 4 is 3 and X's geometric mean. In other words, 4 equals the geometric mean, or the square root of 3 times x, geometric mean of 3 and x. Okay, so just remember that anytime you have an altitude going to a hypotenuse, chop the hypotenuse up. Now, there is a theorem, that's 50-corollary 1, I think it is, 50-1, that states this very thing, but you got to know how to find it and use it. So here it is, 4 equals square root of 3 times x, okay? And then we're just going to solve that, squaring both sides, so square, square, and this is 16 equals 3 times x, divide by 3, and 16 over 3. We'll just leave it like that right now, equals x. Can I help you?
Yeah. Have you seen this Mrs. Harper?
No, I have not. Sorry. Okay. All right. So there's your value of x. A great way to get y now, there's a couple ways to do it, but the best way now is to go ahead and use Pythagorean theorem. You have this triangle right here. It's a right triangle, and you now know 2 of the 3 sides, so let's do 4 squared plus 16 thirds squared equals y squared. And just solve that equation real quick. Let's do it. This is 4 squared plus 16 over 3 squared. And I get 40, 40, 40, 40, 40, 40. Anyway, and I'll take the square root of that. And I get y equals about 6.67. Okay. All right, find the, just a couple more, guys. We got this. Here we go. Find the exact length of a hypotenuse. Oh, so easy. These are fun. So the formula, I call it formula. It's not formula per se. The formula is, or the idea is, that this one and this one are 45. It's a 45, 45, 90, which means if this is x, this is x, this is just x rad 2. Well, that just means if one leg is 8, just put 8 down there, and that means this one is, honestly, 8 rad 2. That was easy. Okay? If they give you the hypotenuse, then you got to work a little bit harder, but it's not bad either. All right. Draw a pentagonal prism in 1-point perspective. I don't have to use a pencil with an eraser. I'll just use this, okay? A pentagonal prism, and you can draw it a couple of different ways. I'm going to go ahead and, when it's in 1 point, we usually put the face in the front, so pentagon. So fun, right? Some of y'all got into this stuff. Okay, didn't say it was regular. It's whatever. All right. Now pick a vanishing point. Doesn't matter where it goes. And then we'll just sketch in our perspective lines there. Okay, so there's my perspective lines, and then we'll just, again, sketch the back. Let's draw in the back one. So we're just gonna, what I like to do is do parallel. So just make a line that's parallel to the other line and connects to those same vanishing lines. So then from here, make another one that's parallel to that one. And again, parallel, parallel, and parallel. And then these, and then connect your corners, and you're good. I feel like Bob Ross over here, you know what I'm saying? Here we go. We're gonna do happy little lines. Here we go. All right, so there you go. And then if you had to erase your lines, you'd have a nice looking, that's pretty decent looking. I mean, for an immature, that's not too shabby, if I say so myself. I'm going on the road. Look out, Bob Ross. I'm ready for you. All right, number 40. This is a mid-segment. Once you know it's a mid-segment, you get some facts about mid-segments because they connect midpoints. So this has to be 8. You also know that this has to be 22 because it's across from that. Okay? All right, cool. That was easy. Is that it? Yay. All right. We did it. All right. Keep working hard, guys. I appreciate you. And like and subscribe and hit whatever. All right. Have a good break if I don't see you.